We all know what anesthesia does. It makes you fall asleep before surgery and wake up with no memory of what happened. But how does that actually work? How can a few milliliters of chemical make you unconscious, unresponsive, and completely unaware, and then bring you back, seemingly unchanged? In today's video, we're going to explore one of medicine's most fascinating and mysterious tools. What's really happening inside your brain under anesthesia, how scientists discovered it by accident, and why, even after more than 150 years, we still don't fully understand it. Before we get into the science, let's get one thing straight. Anesthesia isn't just one thing. When you go under, doctors are actually combining different types of drugs, each with a different job. Some make you unconscious, others block pain, some paralyze muscles so surgery can be done safely. Together they make a delicate, reversible state. The story starts in the 1800s. Surgeons used to operate with no pain relief. Patients were held down while knives cut through living tissue. It was brutal. Then in 1846, at Massachusetts General Hospital, a dentist named William Morton demonstrated something extraordinary. He used a gas called ether to make a patient fall unconscious during surgery. When the patient woke up, pain-free, the audience erupted. It changed medicine overnight. Ether, chloroform, nitrous oxide, the earliest anesthetics were discovered by trial and error. But understanding why they worked, that took much longer. Now here's where it gets strange. We know anesthetics somehow disrupt communication between brain cells, but not exactly how. Unlike painkillers that target specific receptors, anesthetic molecules are small, simple, and seem to work across the whole brain. Some theories suggest they slip into nerve cell membranes, changing how electrical signals pass. Others point to specific receptors like GABA that calm brain activity. The truth might be a mix of both. What's clear is that anesthesia doesn't just turn the brain off. Brain scans show that under anesthesia, certain regions disconnect, especially those responsible for self-awareness and sensory integration. It's more like unplugging the network that lets you exist. So under anesthesia, there's actually three main stages. Firstly, sedation. You're relaxed, maybe sleepy, but still responsive. Then general anesthesia. You lose consciousness completely, can't feel pain, and won't remember a thing. And local or regional anesthesia. Only a specific part of the body is numbed, like with dental work or epidurals. Anaesthetists constantly adjust doses to keep patients in a safe, balanced state, deep enough not to feel pain, but shallow enough to wake up again. So what happens when it's time to wake up? The anaesthetist gradually reduces the drugs, and the brain begins to reconnect. The regions that control consciousness and movement restart, like switches flicking back on. Some people dream, others wake feeling as if no time has passed at all. And in rare cases, a phenomenon called anesthetic awareness occurs, where patients regain some consciousness during surgery but can't move or speak. It's incredibly rare, but it shows just how fine the line is between being under and being awake. Even today, scientists are still trying to answer the big question. What exactly does anesthesia do to consciousness itself? Some researchers think it could help unlock one of neuroscience's deepest mysteries, how the brain creates awareness in the first place. By studying what happens when consciousness disappears under anesthesia, we might learn what makes it exist at all. Newer drugs are also being developed that work faster, wear off more predictably, and are safer for the brain, especially in elderly patients. And anesthesia monitoring is becoming more precise, using EEGs to measure depth of unconsciousness in real time. Anesthesia doesn't just make surgery painless, it makes modern medicine possible. Major surgery and even open heart surgery would never exist without the ability to safely switch consciousness off and back on again. And yet, for all our progress, there's still something almost magical about it. A chemical that can pause a mind, suspend pain, and then bring a person back, perfectly intact. Thanks for watching. If you enjoyed this video and want to learn more about the mysteries of the human body, don't forget to subscribe to Procura. And let me know in the comments, what's scarier to you? Being awake during surgery, or the idea of being completely gone, even for a few hours? See you next time.